Okay, we got a conical tank filled to within 2 feet of the top with olive oil weighing 57 pounds per cubic foot. How much work does it take to pump the oil to the rim of the tank? So let's get an idea of what this tank looks like. By the way, the tank is 10 feet deep. So we've got this conical tank right here. And goes back to the origin. And we're going to say that this line that forms a boundary of our tank, okay, we're going to say that that line is y equals 2x, okay, and we're going to say that the top of our tank, very, very tip top of the tank, this will have a depth of 10 feet. Okay, so what we have in it now is we've got some oil in this tank, and the oil is filled all the way up, not quite to the top, but very close. There's 2 feet of space left, so there's 8 feet of oil. Let's get a different color. 8 feet of oil in the tank. All right. So we need to know how much work does it take to pump the oil to the rim. So remember, work is equal to the integral of the force equation. Okay. So we've got some math to do on this guy because we've got to be able to determine what that force equation is. We don't really know right now. So here's one thing that we do know. We do know that we've got to pump the oil to the rim of the tank. And if our rim of the tank is 10 feet tall, then the distance from the top of the tank to where the oil is would be 10 minus y. Now that's going to be important because it's going to tell us how far we've got to move that oil. All right, in this case it happens to be 2, but there could be some changes in there because there's a lot of oil already in the tank which needs to be pumped to the top. So how far does that lowest point have to go, or any point have to go? It has to move 10 minus y units to get to the top of the tank. The other thing that we need to look at here then is some volumes, because in order to move the oil, we're going to move a lot of oil, and we need the volume of one piece of the tank. And if I have the volume of one piece of that tank, the work done is equal to the weight of that one piece. So volume is going to be a circle, so it's going to be pi times radius times the thickness, okay? Or in this case, times height. And for us, we're moving along the y-axis. So the h part is going to be represented by dy, okay? The change in y, that's your thickness part. So the r value then needs to maybe be written not in the form of y equals 2x, but maybe in the form of x equals 1/2 y. That way we've got a constant variable. So if I'm going to have dy for this, then x equals 1/2 y will be my radius. And then pi, of course, is going to be, forgot that squared. Pi, of course, then stays as part of the area of, or volume of a circle. So this equation then becomes volume equals pi times 1/2 y squared dy, or pi over 4 times y squared dy. That's the volume part, and it's important that we have that, okay? The next thing we need to do is figure out how much one slice of that weighs. And so what we would do is we would take the 57 pounds per foot cubed and multiply it with the volume. That'll give us the actual weight of the thing. If I know what my cubic weight is and I know how much I have, when I multiply those together, that gives me my whole thing. So then I'm going to take 57 times pi over 4 y squared dy. All right? And that'll get me this should get me really close to starting to get close to the force required to actually lift that oil up. Lastly, I need to figure out how far I'm lifting. Remember, when we did these previous problems, I had to know how far I was moving stuff. And so to actually get the amount of work done to complete my force equation, I've got to multiply this guy by the distance that it goes. Okay, the distance the oil goes. And remember, that oil changes as it moves. So the distance is going to be 10 minus y units. And so everything's in terms of y. So my force equation, force of y is going to be 57 pi over 4 times y squared times 10 minus y times the dy, the change in y. And this will be what I integrate right here. And how far are we moving all of this? Well, we're moving it all to the rim of the tank. And so we're going to actually move every... So what we want to do is we actually, if the distance to the rim is 10 minus y, I just basically need to integrate from 0 to 8, because that's the depth at which we're currently sitting. So from 0 to 8, I'm going to integrate this guy right here, which is the volume and the weight of one slab, and then how far we're moving it, which is the 10 minus y units. So we could have 57 pi over 4 times y squared times 10 minus y dy. And again, the 0 to 8 is the depth that we're at, and the 10 minus y covers us to the rim. Okay, so we get the beginning to the end of the actual depth of the oil, and then the 10 minus y gets us from that to the rim of the conical tank. So integrate this bad boy, and again, he actually doesn't integrate too bad, whether you do it by hand or whether you do it by calculator. So what you end up with, though, is 30,561 foot-pounds of work. All right. So there you go. That's a tricky question. There's a lot going on in there, and it's maybe something where you have to slow down and watch twice or ask another question. But there you go. Section 3 stuff.